All right, let's work through a few homework problems. So here we're given the equation of a line in slope-intercept form. So remember that slope-intercept form is y equals mx plus b, where b tells us the y-intercept, and it's not the entire y-intercept, it's the y-coordinate of the y-intercept. A point on the y-axis has an x value of 0. If we're on the y-axis, we've not gone over any. So any point on here, the x-coordinate is 0. So the number that doesn't have an x by it, that tells us the y-coordinate of the y-intercept. And then the coefficient of x tells us the slope. This is only true if we solve for y. If y is not by itself, then we would have to isolate it for y and put it in this format to read off the slope and the y-intercept. So in this case, our slope is 3 over 7. That's the coefficient of x. And our y-intercept is 0, 1. So let's pull up some graph paper and scratch it and see if we can get a graph from here. So our y-intercept, we said is 0, 1. Slope is 3/7. Remember what slope is, it's rise over run. So from an existing point, from any point that we already know, we would rise 3 and run 7. So from the y-intercept, we go up 1, 2, 3 units, and then we go over 1, 2, 3, 4, 5, 6, 7 to here. Oops. So that gets us to a second point. And with 2 points, then we can connect those, and that'll give us the equation, or that'll give us the graph of our equation. So that has a y-intercept at 1 and a rise of 3, a run of 7, so a slope of 3/7. All right, the next one. They want us to do the same thing, use form to graph this equation. Well, we have to put it in slope-intercept form. So to be in slope-intercept form, we have to have y by itself. So we need to get the 5x off of the left side. So if it's a term, we do the opposite. The opposite of a minus 5x would be a plus 5x. If we add 5x to the left, we add 5x to the right. So minus 5 plus 5 makes 0, so no x's on the left. Bring down the y. And we have 2 terms. These are not alike. One has an x, one doesn't. So let's put the term with the x first and the term with just a number second. This is in our slope-intercept form. Y equals mx plus b. So once it's solved for y, the coefficient of x gives us the slope. The number without an x tells us where the y-intercept is located. So the y-intercept is 0, -3. The slope is 5, or as a fraction, we could call that 5 over 1. So if we add some graph paper, we're going to plot a y-intercept of 0, -3. So come in here and 0, -3. And then 5 over 1. You might say, why are you making it a fraction? That's messier. Well, it's because slope is rise over run. To have a rise over a run, it helps to have our slope as a fraction. So if we put it over 1, that's the same thing as 5. So now, from our existing point, we can rise 1, 2, 3, 4, 5, and then we can go over 1, and that'll tell us where another point is. This one, we have room to do that again, so we could rise 1, 2, 3, 4, 5, and then go over 1. And these points are going to be in line with each other. So this would be our graph of the equation they gave us. Y-intercept of -3 has a slope of +5. All right, same type of thing for the next one. We have x equals 7/3y. We needed y by itself so that we can read the slope and the y-intercept. So to get the y by itself, the operation here is multiplying. The opposite of multiplying is to divide. So we're going to divide both sides by 7/3. 7/3 over 7/3 cancels, leaving us y. And then how do we do this? We have x. A fraction bar is equivalent to saying divided by 7/3. Well, if we divide by a fraction, we keep the first term, or keep the first part, change it to multiplying, and we flip the second part. So dividing by a fraction is the same as multiplying by the reciprocal. So let's change this. Let's put the y on the left, and on the other side, let's call it 3/7x. So that's almost ny equals mx plus b. You might say, well, why don't you say almost? This is okay exactly as we have it. Notice there's not a constant on the end. We can leave it like this, or we can say since there's not a constant, then our b is 0. Our b is 0. That lets us know that our y-intercept is at 0, 0. Remember, for the y-intercept, the x-coordinate is always 0, and the number that's by itself, when we're solving for y, that tells us the y-coordinate of the y-intercept. And then our slope is the number beside the x, so the 3/7. So let's graph this. If we have a y-intercept of 0, here's our y-intercept. And then we have a slope of 3/7. So we go up 3, 1, 2, 3, and then we go over 1, 2, 3, 4, 5, 6, 7. And then we draw a line through them. So the key is isolating y. Once we isolate y and we get our y-intercept, plot the y-intercept, and then use the slope to get another point or multiple additional points. I just got one more because if I go up 3, I can do that, but if I go over 7, I'm going to run off of the grid. But 1, 2, 3, when I go over 7, that'll be 1, 2, 3, 4, 5, and I still got to go over 2 more. So 1, 2, and notice, yeah, that would be on my line. The last problem or two has us take the information of the slope and the y-intercept and write the equation. The previous problems gave us the equation, and we had to determine the slope of the y-intercept from the equation. Here we're going in the other direction. So if our equation is in the form y equals mx plus b, if we know that the slope is -8, we can put that beside the x. And if we know b is -1/5, we just put that in place of b. So this is the equation of a line that has a slope of -8 and a y-intercept of -1/5. Next one is the same idea. If our point slope form, or I'm sorry, slope intercept form is y equals mx plus b, we have a slope of 0, so put a 0 beside the x, and then our y-intercept is -8, so -8. 0 times anything is 0, so we're left with y equals 0 minus 8, or just negative. So it's just plugging into our formula. This only works if we know the slope and the y-intercept.